This week, NASA put out a informal request for proposal stating that they're looking at launching a mission on a heavy lift rocket to explore the moon Europa, which is one of the moons of Jupiter, with the Europa Clipper mission. This mission has been previously tagged for the SLS rocket, which would launch it directly towards Jupiter. The SLS being as massive of a rocket as it is, as powerful as it is, it could do this direct trajectory. Europa Clipper is larger than any spacecraft that we have ever sent towards that planet. And as a result, it would be able to do some pretty great wonders. The mission requires a ginormous spacecraft because it's going to orbit around Jupiter and it's going to do some really, really great science. The spacecraft is about 6 metric tons, which is huge. That's bigger than Cassini, which was just a little bit less than that. And to send it directly there is an incredible achievement. It requires an incredible amount of energy. The only rocket other than Starship that is still being developed that is capable of doing so is the SLS rocket, and that has been tagged specifically to do this mission for a long time. There's been a lot of speculation, though, as to whether or not it'd be able to do that because the SLS rocket is currently tagged only for human exploration missions. But could a commercial rocket actually do this? Well, there's a huge history that goes into that, and a commercial rocket could do it for far cheaper, an order of magnitude cheaper than any SLS rocket. SLS will cost $1.5 billion for a steady state launch. With the Falcon Heavy in its expendable configuration, which would be required, it would be a tenth of that cost, only about $150 million roughly, to make this massive mission. The Europa Clipper mission will be able to really study that moon, which is really interesting because it has potentially a liquid water ocean underneath its surface, and we'd love to be able to study it more. There may be life on there. We don't know. We're hoping to be able to understand that as a result of this very important mission. We'll be able to study some of the other moons of Jupiter and do some other cool things. It's going to do regular flybys of Europa. Now, some of you may ask, if the whole mission is to study Europa, why wouldn't we want to do an orbit mission of there? Well, Europa is very, very radioactive. Yeah, kind of. Jupiter has a magnetic field similar to Earth, similar to the Van Allen belts, and those of you who study a lot of space will know that you don't want to be in the Van Allen belts for an extended period of time. Jupiter's is way, way, way worse than anything we have on Earth. And so you're going to do these constant flybys of Europa to be able to extend the mission, cover the entire planet, and be able to send the data back. And then you're going to go far away from the surface so you're not in these magnetic field regions that have this radioactive material for very long. And as a result, you'll be able to have the spacecraft operate for much, much longer. So let's talk about getting that massive mission there. Well, there's 3 potential rockets that could possibly do it at all. And those are the Delta Heavy, the Falcon Heavy, in the fully expendable configuration, and the SLS rocket. The SLS rocket is the most powerful of these and could launch it directly to Jupiter in about 2.5 years. In a lot of ways, that makes the mission much, much simpler. You're not going to be in space for that long, so you can get there quicker and do science. But the availability of the SLS rocket is in a little bit of question. We had a test firing recently that didn't go according to plan, and the maiden mission of the SLS rocket, which is currently scheduled for the end of this year, is in question. There may only be 4 of those that are ever built. I'm pretty sure there will be at least that many, and none of those at all are tagged for the Europa Clipper mission. So it has been long decided that by Congress that they wanted it to be used to send this mission, although they're starting to release, especially now as the senator that was in charge of that no longer has quite as much power with the change of the makeup of the Senate. Okay, let's talk about the specific proposal. NASA wants a rocket that can lift the Europa Clipper 6-ton spacecraft with a C3 energy of a little bit over 40 kilometers squared per second squared. That number it's just a representation of how much energy you can send a spacecraft to. To get something to Mars takes about 20-ish kilometers squared per second squared. So this is going to be able to carry it far out there. To go all the way to Jupiter, you would need about 80. And it's going to do a flyby of the planet Mars. Now, one of the trajectories that I had long been looking at as possible by a Falcon Heavy was similar to the Juno mission. Juno went on a 2-year orbit around the sun and did a deep space maneuver at the far point, brought it back to Earth so that it could do a flyby and use that flyby to send it all the way out to Jupiter. That would have worked, but it would have required about 700 meters per second of delta V. While that's far more than Europa Clipper will have, they really didn't want to use that delta V, and so what they would have done is put a small booster stage that was a solid rocket that would have kept for a year, and then use that for that deep space maneuver, which would have allowed it to get all the way to Jupiter. But that adds another stage, it's an extra cost, it's a big pain. What the scientists figured out who were plotting this trajectory is, hey, if we do a flyby of the planet Mars, which is possible if we launch in the year 2024, then we don't have to do that deep space maneuver. That's a very high energy thing. There no doubt will be some small ones to get everything on course, but that's all planned for anyways. They do this flyby of the planet Mars, they effectively get this free, and then they can fly by Earth like they would with their Earth-Jupiter EEG mission, go all the way out towards Jupiter and be able to orbit the planet, no problem whatsoever. So what would it take to do that? Well, you would need a characteristic energy of about 40 kilometers squared per second squared. This characteristic energy, C3, is the amount of energy beyond escape velocity. It's the best metric really to send a mission, because if you use the energy closer to Earth, then it just goes further. That's totally within the realm of Falcon Heavy. Falcon Heavy could put that payload with a characteristic energy of about 43, 44, and it only requires about 41. So Falcon Heavy could absolutely do that, and the mission isn't that big. It could easily fit inside of a Falcon fairing. They were actually going to build a special fairing with SLS rocket just for that Europa Clipper mission. So it's totally possible to do this. Well, what about Delta Heavy? Delta Heavy just doesn't have the same capabilities as Falcon Heavy for the relatively low C3 of 40 kilometers squared per second squared. You would need something much less massive for it to be able to do that. If you're looking at the characteristic energy which it could provide, you got about 20 to 25. I didn't figure the exact number. This is all according to the Performance Vehicle Calculator, which you can find a link down in the description below. That would allow it to fly by Venus, and therefore it would be very similar to the Cassini trajectory. Well, this caused a couple of issues. Galileo, for instance, which was the last mission that we had that orbited Jupiter, other than the Juno mission that's there currently, it flew by Venus and was able to do some pretty good stuff while doing so. But that was never really the design, and Venus is close enough where you have to do heat management way, way more carefully than you do for a mission that's just going out to the deep space of Jupiter. It's a lot warmer, the sun's a lot brighter, and you just have to manage that properly. Well, the Galileo mission had to keep its mirrors folded in. By mirrors, I mean the parabolic antennas that were used to communicate back with Earth. And until it was no longer going to be close to the inner solar system, they couldn't unfold it. They couldn't actually unfold it ever because it had kind of gotten frozen in place because it had been in space so long. And it caused a huge amount of uproar. And as a result, it wasn't going to work as well. We could never get as much data as we wanted from the mission. We had to suffice with a lower bandwidth antenna. All the way out to Jupiter, that makes life way more complicated. Cassini, though, was designed with that in mind from the beginning. Originally, Galileo, well, it did launch on a space shuttle mission. and it was going to use a hydrogen upper stage, but they decided after the Challenger accident that that was a little bit too risky to put liquid hydrogen inside of the cargo bay of the space shuttle. And so they replaced it with a solid rocket that allowed it to continue on its mission. But it didn't have as much power, so it had to do this Venus flyby to make everything work. So Delta Heavy, even if there was going to be some rockets, would have to involve a Venus flyby, and that just wasn't going to cut it. Falcon Heavy, if you were going to do the EEJ mission, similar to how Juno did it, would have to have basically a kick stage that would fire off at this far point that would allow it to return back to Earth faster and do a flyby and continue back on its way. It could have worked, but it would have been some extra effort. Either way, you're going to have to redesign the spacecraft. The scientists and engineers discovered that by doing this flyby of the planet Mars, the MEGA Mars-Earth Gravity Assist mission, you can save this rocket. Essentially, you can take Europa Clipper as it's currently designed and get it all the way to Jupiter on a Falcon Heavy. Now, this is going to be a fully expendable Falcon Heavy. May be the only fully expendable Falcon Heavy that ever flies. But it could totally do that, and it is actually certified to carry these high-value missions because it's had 3 successful launches. They've submitted all the documentation. Even the Air Force has said that this is certified for their high-value missions too. The high-value missions are a similar level of certification between the 2 different agencies. So Falcon Heavy can do this mission. They can launch it earlier, and as a result, it'll actually arrive to Jupiter at about the same time. When the mission's in space, it's actually a little bit cheaper to maintain than when it is on the ground, because you don't have to have the footprint, you don't have to have the environmental controls. It's in space, it's doing what it needs to, and you don't have to do any major redesign at all. Overall, this is a brilliant suggestion, and congratulations to the JPL orbital mechanic wizards who figured this out. Really great trajectory. It's totally possible to have the mission to launch in 2024, and we don't have to rely on the SLS rocket. It'll save the taxpayers money. Everyone's happy except for the people who are building SLS, and even then, they get to concentrate on building the stuff that really counts. Now, Starship could theoretically launch this, although Starship has its own issues with this. You really would have to refuel it a number of times to get it to do this, and quite frankly, it's not going to have the level of certification. You have to have something that's going to be certified for certain in 2024, and that's really hard to even say that that would be possible. As a result, though, I'm quite sure that Falcon Heavy will do its one and only fully expendable mission to carry Europa Clipper all the way out to the planet Jupiter, and it will be amazing, I'm sure. Thank you guys so much for joining. Let me know whatever questions or comments you guys have. Thank you to the guys on the Space Stack Exchange that helped me to come up with this question. And thank you also to my Discord members for helping me brainstorm this. You can find a link below. And to my Patreon supporters, you guys are amazing. I couldn't do all of this without you. Let me know whatever questions or comments you guys have about anything else. And until next time, keep on tracking. Take care and keep the interest in space exploration.